Hello, and welcome to Persistence Data Mining's Soilytics Soil Nutrient Mapping Solution. Today, we're going to be going over setup so that agronomic service providers and farmers can obtain better soil nutrient data to make better input decisions. So we're going to start. As you see, this is the box the sensor comes in. It looks quite large. However, the actual sensor is not quite so big. So we're going to take out this first block and go through and start taking out the cables so that we can get you set up and ready to go in the field to map the nutrients for better input decisions. Here's the sensor. We're also going to be connecting the probe with the cables. Now, if you're working out in the field and are unable to connect to a standard outlet, you'll be using the containers in the black cases. Today we're going to be plugging into the input into the wall. The small case contains the cable for the computer. Hopefully before you come out in the field, you'll have most of the devices charged. The sensor does require its own power source at all times. So what we're going to do is we're going to plug in the power source. Now we've marked the power source cable, as you can see, with a red dot. So on the back of the sensor, you're going to see the same red dot here. We're going to take this cable, insert the cable, and screw it on so it stays connected. Now remember, sometimes in the field there is going to be vibration, so you really want to make sure these connections are tight. Okay, we're going to connect the XLR cable. It's a 3-prong cable. Make sure to input this correctly, and you'll hear it snap into place. We're then going to connect it to the sensor or probe, and we're going to test it to make sure that it works. The light source is located right here on the front of the probe. We press that. As you can see, we've got light, we've got connection. Now we don't need to leave that on. Next, we're going to connect the fiber optic cables. As you can see here on the front of the sensor, there's a twist tie, and this actually is where the fiber optic cable connects from the sensor to the probe. We're going to unscrew the black cap. We're going to insert the cable. Now this right here is one of the most delicate pieces of this equipment. We are going to screw it on, making sure again that it's connected well. Due to vibration, you don't have to use any tools in order to connect, but you do want to make sure that you have a tight fit. Again, to keep the cable clean and the sensor clean, we only want to remove these and then quickly place them into the sensor. Now, as you can see, there is a screw cap here, and we're going to thread this through, insert it all the way into the sensor, and then connect, and again screw this cap tightly so that everything is well connected. All right, next on our list, we're going to get out the computer. The Tough Book is designed to be in the field and field ready. As long as it has been properly charged, you should have no problems. So located here in the second pouch is the GPS connector. Now, some of you that are familiar with the Tough Book might be familiar with the fact that it does have its own internal GPS. We use an external GPS for added sensitivity so that it gets better readings for our location tracking. We're going to just plug this right in the side into the USB port, and it connects to the back. All right. During setup, we made this real easy for you. To enter in the passcode is the exact same name as the user ID, so it's capital P, capital N, capital I. In order to get there, double click. The screen will come up. We will hit capital P, capital M, capital I, and launch the system. All right. Now, one of the tricks in the field is making sure that the sensor is the Wi-Fi source for the Toughbook. So initially we're going to go in and make sure our Wi-Fi is correctly enabled to number 28164. It should connect automatically, but that's going to get you into our acquisition software and connect the sensor. And I probably should have closed all of these out before I got it. Now, if you look here at the bottom, there is the acquisition software. Once we're in the acquisition software, we're going to connect to the GPS. So we're going to hit the setup button. Once the setup button and the system is connected, the latitude and longitude will automatically populate. If you have problems, remember that some places in the field do not have the best connection. Again, we are doing the best we can to get you accurate information. All right, and there, our system has populated despite the fact we're in a big building. All right, so the next thing we're going to do is we're going to push the start button. That's going to initialize the sensor and the computer to connect. We've connected now the GPS. Now we're going to connect the sensor. So we hit the start button and we wait for that box to turn green. Now again, if you have problems at this stage, go back and double check your Wi-Fi connection to see if it has somehow decided to connect to something else. Might take a little bit. As you can see here, we've got a green go box. Now the next part is calibrating the system. We do this just a couple times a day, so before you go out into the field while you're in the setup process, it's best to calibrate the system. Now there are a few things that you want to make sure that you've done prior to entering the field. One of those is cleaning the spectrolum. The spectrolum is a white reference which gives us a baseline reading to compare against to make sure that the sensor is working accurately when we're in the field. Now as you can see, there are a few circles. This one has not freshly been cleaned, letting you know that the entire surface does not have to be cleaned because we're actually going to be placing the sensor directly on there. Again, when you're going out in the field, it's best to clean this the night before, pack it away, pat it dry. Do not use any chemicals on it. It will change the signature. We use fresh water and some sandpaper, and sandpaper it in small circles. So we're ready to calibrate. We calibrate, make sure the light source is on in the wand. We're going to find a clean surface and we're going to just lay the sensor on there and we're going to press the collect white button. Now that's just going to take a minute. It'll show red as it goes and then it'll turn green. So basically, at this point, we've got the 2 green lights on our system letting us know that we're ready to go out and start sampling. Now the next thing you need to do is you do need to find a location in your system of where you're going to put these. So before we get started, we're going to browse our locations. On this particular system, we are going to set up for Hubbard. And that's where we will be storing our new data. Just a moment. So quickly I will show you with our sample bags how that will work for our first few samples. So sample bag 1, these are homogenized samples. As you can see here, we've taken a 6-inch core, put it in the bag, and basically homogenized it. Our upcoming system will have a self-automated system that will take these readings in the field and take the core for you. But right now, as we move through the development process, we will have to homogenize these ourselves. Again, make sure that the light is on. Place it into the bag. You should see no light. We're going to start our sample number. If you're in a field and leave the field, turn off the system, you can input the first sample number right here and how you do that, and then it will count up from there. So this will be sample number 1, and it will auto-populate and move up as you go through the field. So we're ready to go. We're going to hit collect. And as you can see, the sample number has now moved to 2, so we're ready to scan sample number 2. Please call us if you have any questions. Thank you for watching this video on how to use the Soilytics soil nutrient mapping solution to help make better input decisions. We're glad to have you on board, and thank you for being a customer as we move forward to change the world, to feed the people, and increase revenues in agriculture.